Dear aspirants, welcome to my channel. This is a model question paper 2 Electronics and Communication semester 2 Applied Electronics 1. Subject code is 25EC21I. So this is part D 5 marks question. Okay, if you attend 5 you will get a 25 marks. Given atomic number carbon 6, silica 14, germanium 32. Determine the electronic configuration and classified based on their electric property and explain the reasoning. So we have to classified electronic configuration and classification of the elements. Here you just see the carbon, it is in C, atomic number is 6. So electrons distribution is 2 to 2 comma 4. There's a 4 electrons in outermost shell of the valency electron. Same way carbon, which is having a, it's behave like a non-metal, and it is having a property of similar to the semiconductor. The next element is silica. It is an atomic number is 14, electronic configuration 2 comma 8 comma 4. There is a 4 valency electrons it is having. But silica also one of the semiconductor. It will give the conductivity of between the conductor and insulator, which we can use for electronics devices. Next they given germanium Ge. Atomic number is 32. Electronics distribution 2 comma 8 comma 18 and 4. It is also having 4 valency electrons. It is also behave like a one of the semiconductor, which we can use it for transistors and diode. The reason for classification, why the reason we have to classify it. Okay, so the reason is each element having a 4 electrons, generally it is a common, it's behave like a semiconductor. It has mentioned above the properties. So it is either good conductor or not good insulator. Say maybe conductivity may be increased with increasing temperature. It may be varies from temperature. It is having a, it is formed like a covalent bond easily. Next question is, you are designing the voltage regulator circuit using a Zener diode. Explain how would be chosen the Zener diode. The series resistors maintain constant voltage across the load. So coming to the circuit diagram, for Zener diode, circuit diagram is it is the circuit, this is the circuit diagram which is having a supply voltage. Supply voltage has given series resistor IR, IL, okay. It is having a Zener diode IL, IZ, it's a load, it is a OV. The Zener diode voltage, how it will be regulate the voltage. This Zener diode, it is used for, we can use it for reverse bias, maintain the constant output voltage across the load, even input the voltage changes. It will be maintained constant until the we have to input the load. Why we have to choose the Zener, why we are choosing a Zener diode. So coming to the selection of the Zener voltage, selection of the Zener voltage means in a Zener diode, the break voltage will be equal to the required output voltage, whatever break voltage which will be equal to the output voltage. For example, if you the required for 50 output voltage is 50 volts, we have to use Zener diode is 50 volts. So coming to the condition, input is equal to output, Zener voltage is equal to voltage output. So coming to the selection of power rating. So in the power rating, the Zener diode should be handle the required current safely, and the power rating will be greater than, so PZ is equal to VZ into IZ. Okay. We are choosing a series resistor. Why we have choosing the series resistor? In a Zener diode, series resistors which will be limit and excess current through the Zener. If you arrange series resistor, it having a limited and it will flow to current flow through the excess of current flow through the Zener. This is the formula they are going to represent. RS with which series of resistor. This is an voltage. VZ is Zener diode. IZ is Zener current and load. It is a diagram what we have learned above. Same diagram. Coming to the working condition. If you input the voltage, okay, if you input voltage increases, Zener diode conduct the more current and maintain the constant voltage. So input voltage if you decreases, Zener current also decreases, but output remains same nearly until the constant. So that's why the load get stable. That's why they are going to use the Zener diode. To design Zener voltage regulator, how they are going to design the Zener voltage regulator. So before selecting any Zener diode, we already know the definition which required breakdown voltage, any breakdown voltage, but proper power rating it will give selecting, and suitable for we have used suitable for series resistor for limit the current, and it maintain constant voltage until across the load. The next question, describe VI characteristics of Zener diode. Explain the significance of Zener breakdown voltage. Its users maintain the constant voltage. So coming to the characteristics of VI characteristics of Zener diode. The Zener diode, especially they go designed for PN junction diodes. It is operate reverse bias, the region of the voltage to regulate. So this is the forward base the characteristics of the curve. So this is the characteristics of the curve. It is in forward. Here they mention forward voltage, forward bias, reverse bias, forward bias. This is Zener breakdown. VZ, I maximum. This is an voltage. This is they're representing the dotted lines which will be in I maximum. The breakdown will be takes place. This is the breakdown I naught. So Zener constant voltage, reverse current will be flow, reverse bias, forward bias. This is the characteristics diagram. So coming to if the forward bias, Zener diode behave like a ordinary diode. Current increases rapidly after forward voltage reaches 0.7 volt in the silicon diode that they represent in the diagram. You can see there. So coming to the reverse bias region, in the reverse bias only a small leakage current flow initially. Okay, initially very small leakage current will flow. After that the reverse voltage reaches to the Zener breakdown voltage. The current increases suddenly. The voltage across the diode remain constant. Okay, the Zener breakdown voltage nothing but reverse voltage which breakdown occur. Whenever reverse will be there, the dotted line they represent that breakdown occurs, that we call it as an Zener breakdown voltage. The expression you can write VR is equal to VZ. So here Vz is a Zener breakdown voltage. Coming to the significance of the Zener breakdown voltage, so we maintaining constant voltage output voltage to protect the circuit from voltage variations. Okay, any voltage variations express you can protect. User for voltage regulations we can use. Important for power supply circuits. So we have definition of breakdown. You will get a V output is equal to Vz. Even input voltage also changes. So users and maintain constant voltage. Use in the maintaining constant. What is the use of maintaining constant? In a Zener diode connected to reverse bias across the load. When supply voltage changes, Zener current changes automatically. So when the output across the load remain constant, Vz thus voltage act as a voltage regulator. Coming to an applications, we can use it for voltage regulator, overall voltage protection, power supply and electronics circuits. This we can use. The next question, list the three BJT configuration. Identify which one is primarily used for voltage amplification. BJT configuration nothing but bipolar junction transistor which will be connected three different configuration depending upon terminals, common input and output. The configurations, it is in common base, common emitter, common collector. In the common emitter configuration, the mainly used for voltage amplification because it provide high voltage gain, it having high current resistant gain. It will, if you moderate input, output and resistant and output signal amplified effectively. So coming to an advantages, CE configuration, it is having a high power gain, better amplification, widely used for amplification circuits. So if the content is useful, please subscribe my channel and share support. Remaining question I am uploading next video. Thank you.